Hey everyone, how's it going? Welcome back. Today is the last day, and this, I believe, is the last stream of GHW. And I'm so excited to be here. How's everyone doing today? Hello, welcome. Let's give everyone a couple of more minutes to trickle in, and then we'll get started. Today's stream was supposed to be extremely hands on, but I realized while preparing that it's going to be difficult for everyone to replicate. So I am going to give you so many resources to continue doing things later. But yeah, I have so many resources. I'm going to keep sharing links. We're going to keep going over different links and materials that I have gathered for y'all around every topic. So should be fun. How has GHW been for y'all? Have y'all been having fun? Have y'all had any streams that you completed the hands-on thing with? Hello, welcome. And have you submitted challenges? How many challenges have y'all been submitting? It's been nice. That's so good to hear. I'm so glad you're enjoying your GHW. Amazing. Great. So, another minute, and you submitted 10 challenges. That is incredible. That is absolutely incredible. And yeah, that's awesome, y'all. I am so proud of y'all to first, well, turn up every day, which is a big deal, and then actually do things. It's awesome. I know it's not just this, right? Like any other community commitment, I'm sure y'all have academics and like 10 other things to deal with. So this is very cool, y'all. Hello, welcome back, Meru. That is a great question. My current favorite tool is Notebook LLM. If y'all haven't tried that, y'all totally should. Notebook LLM is one of the tools I use a lot to learn things myself. Let me see if I can drop a link for y'all. Notebook LLM. It's an incredible tool to learn. Mm, here's the link. So it usually what it does is it actually like makes your you can basically make any document, any video, any podcast very streamlined according to how you want to learn it and break it down in a way that makes more sense to you. So this is Notebook LLM. You all should definitely give it a spin. But cool, folks, let's get started. So, I was just telling if you have just joined that we're going to do a very basic, very shallow overview of how to use open source LLMs. It's going to be a very short stream. So, I was talking to Sid earlier and I was like telling him that, oh my God, I am so concerned about y'all not being able to keep up. So, I've decided I'm going to keep it short, sweet, and I'm going to send y'all a ton of resources. I have like at least like 20 links open here that I'm going to keep sharing with you as we go because I have a feeling that it's a pretty intricate topic, right? LLMs just generally. So we're going to keep it short, and I'm going to at every given point ask how much do y'all understand, where y'all are at, and then we'll discuss. Okay, so let's jump right into the PowerPoint. So yeah, let's get started with a quick introduction. If y'all are meeting me for the first time, hi folks, I'm Rithvi. I've been a coach at MLH for 4 years. I used to stream a lot, like at least like 8 streams in GHW, but I have been taking it a little slow the last few months, and I am back doing a stream after almost a year. So it's been a nice break, and I'm so happy to be back talking to y'all live, teaching something that I'm learning myself. So it's always amazing to be back here. If y'all ever have any questions or y'all want to connect with me on any platforms, I have them all live on the screen. Feel free to connect with me. And of course, every time y'all learn something across the board in GHW, we coaches love to see what y'all are building. So always like don't think twice about using social media to like tag us and tell us what you've been up to. It's always amazing to hear from you. So this is what we're going to go through today. Uh, What are open source LLMs? In case you all aren't aware of it, we'll discuss some high level terms. Why open source LLMs, right? What's the point of it? We'll talk about VRAM and quantization. That's one of the first things that come into play when you're thinking about choosing a model and how to work with it. And then training. So we won't actually do hands-on things. I'll send you all a notebook, a Jupyter notebook that I used to learn. And if you want to walk through, we'll walk through it later in more depth in case you all want to. But it has a really nice YouTube video attached to it itself. And I'm very excited for y'all to actually give it time because the video itself is like a 2 hour walkthrough of how to use just train a model right from scratch. Then we'll talk about production and deploying open source LLMs. So the whole idea why we're taking open source LLM is pretty obvious when we talk about it. And then because of those reasons, you also have to work hard on the whole process. And then I'll show you all LLM Studio and Olama. So if you all haven't used any of that, definitely will use it. And resources and credits, I'll be giving them as we go because I've taken a lot of images from blogs across the spectrum about each topic, diving in depth. So we will talk about it and walk through it. Okay, so let's dive right in. All right. Open source LLMs. What's the first thing that comes to your mind? So, in case y'all are here for the first time, this is supposed to be an intuition exercise. So, what's the first image that comes into your head when I say open source LLMs or just LLMs in general, right? This is just to establish a really nice image and a really nice analogy before we get started. So, feel free to use the chat and tell me what you think about what's the first thing that comes to your head when you talk about open source LLMs. Have you heard of any models that are open source models? So yeah, take a minute. I'm going to give you all 2 minutes on the clock. It's 5:38 for me, and I'll give you 2 minutes to come up with an answer. Just whatever comes to your head. That is, you don't have to be technically right or even associated technically with the term. So just whatever's the first thing that comes to your mind. Feel free to go ahead and use the chat to talk about it. Wow, we have a quiet group today. Lovely, love that answer. So let me get my mouse here. So Satya Sai is telling free to use for experimenting. That's great. LLMs are large language open source models that are available to open source for free. I also attended Jocelyn's benchmark sessions. I have enough idea. That's awesome. A product that we can access in production. Interesting. Good answers, y'all. Production that we can access is product. Okay. Great job, y'all. So lovely answers. I have another minute left to the time that I've given. So anything else that comes to your head, they're all good answers. Some top answers, in my opinion, are local system, right? And experimenting. And y'all have attended Jocelyn's session. I know Jocelyn has been doing amazing streams. I actually have used a couple of them to learn a bunch of things myself. So I know y'all are very well, equipped for this session. However, this is a very high level overview. So I'm very excited to walk y'all through the whole process. Okay, the minute's over. If y'all have more answers, keep them coming. Y'all know I will address them. Right. So let's move on. Why go local, right? So open source LLMs are more than just open source. I'm trying to think of a better word, right? Why go local? So open source allows you to run it locally, which is a great advantage. But why? Why do I want to run an open source locally? And when I say locally, I mean in any other server or any other GPU that is not owned by a separate company. Why do I want the control over the LLM? Why did people come up with that thing? Yeah, everything will be in our system, but why do we want everything to be in our system? That's a great point. Why? What is the one thing that use open source software even there, right? So why would I bother with an open source LLM in the first place when I have these companies doing so much cool stuff? Why not just use it? That is a great answer. Security. That's a good answer, right? There's one thing that's security, right? Why do I need to bother with security? What kind of companies do you think will bother with security? Agreed. That's a great answer, right? We can have to control it, trace it, secure it, manage it. But why? Why do I want to do that? Why do I want to spend my resources doing that when I have these companies putting in so much money to do the same thing? What kind of industries do you think will not be okay using proprietary software or proprietary LLMs? So, since to protect my, but why do I want to protect my data? Like, it's an LLM. I want it to train, right? What kind of industry? So, I have given you all a hint. I'm going to move on to the next slide and we're going to discuss the pros and cons and then we'll talk about industries, right? Finance is a great industry, right? That's a great answer, right? Finance, and then a big industry would be medical industry, right? Patients data and medical data, right? So let's talk about the difference between open source LLMs and proprietary LLMs, right? So first, open source LLMs are publicly accessed. You can modify it, you can enhance it. Everything is in your control, right? Proprietary LLMs, obviously, precisely. Great answer, Satyasai, right? So private, obviously not accessible. Customization, you can customize it exactly how you want to customize it. Another very big reason you want to be able to do that, let's say you have a tiny application, right, but it's a very important application. So you want the LLM to be able to do that so well and only that, right? So you don't want it to be good at like 100 things. You want it to be really good at one thing so you can customize it down to the T, right? So that is awesome to be able to use open source LLM. Deployment, you can run it in your own environments, and that is very important based on the industry, right? So, as someone who works for one of the AI tools, this is such a common question that we get that hey, can we have a self serve basically refers to any tool or any SaaS that can have a repo that the company can pay for, clone, and basically run it on their own environment, right? And a lot of companies, finance, medical, pharmaceuticals, they need it. And they don't just need it because, oh, we're a responsible company, we need to do some things well. They need it because compliance needs them to do it, right? Think about all the governments, right? They need to keep the data secure and protected. So they need everything on their servers where they can verify everything. So let's say tomorrow there's a legal issue or a compliance issue, they can show that hey, we had everything in control, we have everything in our own system, and it is completely secure. Make sense, everyone? Then there is transparency, right? Sure, as a company I might be compliant, and I'm telling your company that you come to buy the software, and you're like, I'm telling you that hey, I am a completely compliant LLM, I've trained everything is secure. But if there's a security breach and turns out I wasn't following a certain compliance rule, everyone is in a mess, right? So there's a lot more transparency. That way, you know exactly where the data is going, you know exactly how it's being handled, and it's amazing, right? Then we have the cost. We'll discuss cost later because regardless, there are costs. It's not like one is better than the other. The only difference is over here, the costs are slightly more complex because you're paying for the server that it's running on, the cloud environment that it's running on. You're possibly paying for like a bunch of different microservices to make the whole application run, right? Cost over here in terms of proprietary LLMs is much easier because you pay for subscription and that's it, right? And then we have some examples. Have you all heard of any of these models, open source models? Llama 3, Gemma 2, DeepSeek, Quen is the DeepSeek. Yes, that's awesome. Especially if you all have attended the benchmarking session, I'm sure you all have, right? And I think everyone's heard of the proprietary LLMs, right? We have Claude, we have GPT. That is awesome. That is amazing. Lovely. So then you have the control and privacy. We already spoke about this, and then we already spoke about what it's best for, right? So open source LLMs are best for enterprises needing security control and customization, medical, finance. A lot of times when I'm dealing with companies, insurance companies, they're very, very picky about, oh, we can't work with you. Airports, even, right? So a lot of these industries, they need everything to be on their server. So a lot of times they want everything to be self-serve, right? Uh, these are the tech giants, and the simple chart of open source and closed source uh, models. So we have Meta giving us Llama, we have a lot of these, like Google giving us Gemini, and then we have all these Mistral AI, which is one of our major open source models, right? So this is just a quick overview of these models, the tech giants that are associated with it, and the ones that aren't. Right? The RAM math. Okay, so y'all did the benchmarking testing. Have y'all spoken about the RAM math in the benchmark testing? Do you all know what's the RAM math? It's time to get y'all some links. I am so excited. So let me find the right links. Oh, I forgot that reminds me. I'm sorry. I'm supposed to give this to y'all earlier on. I am a little rusty when it comes to streaming. Uh, please check in. If y'all are here, y'all are doing a great job. Y'all are doing so much work. Definitely check in and get those streams on your portfolio. So let's talk about the RAM math. What's a RAM? Do y'all know what's a RAM? Not the RAM, the VRAM. Have you all heard of the word VRAM? Do you all want to take a virtual memory? No, but you're close. It is virtual memory because it's supposed to be a little fast, right? GPU, yes. But where does the GPU come from? Virtual RAM, nope. Let me find the correct articles and keep them ready to send them to you because so this was the first link that I had, making the correct choice between proprietary and open source models. This is a great blog that I found, very concise, very to the point. This I'm going to send you all two VRAM calculators. One is a random one that I found, and then the other one is supposed to be a really nice hugging face one, which I have somewhere here. And God, Olama, where is my hugging face calculator? Found it. Video RAM. Yes, it is called video RAM. So why do you think we're using a video RAM? Okay, so I've sent you all two beautiful articles on VRAM and math, and I've taken a lot of this content from these blogs. So you all should definitely keep these bookmarked. They're very good blogs. So this is a VRAM, right? And if you all want, I'm happy to send you all this article as well. This is an NVIDIA VRAM, and yes, it is a video RAM. So this is the formula that is used for the compute requirements to train a model. Okay, so VRAM is not just based on video, it is also used to train your and used to calculate your GPU or the model requirement that you need on your computer. So let's just give it a second. Oh, and there's this beautiful podcast on calculating the GPU units. So this is amazing podcast that I found for y'all that y'all can talk about. To store data. Oh, yeah, that's it. So VRAM has two other things that we need to talk about, right? So VRAM is basically the usage that you need, the compute power that you need, and this is the formula usually used to decide the compute power, right? So this is one of the formula. However, if you move on, let's first talk about quantization. Do you all know what's quantization? Have you all heard of the term quantization? I have something in front of you that is a very big hint on how quantization works. I have an article for this for y'all as well, but I'll send that to y'all later. Oh, and there's this precision lowering, interesting way to put it. I heard it in physics and chemistry, but I don't remember. Like normalization, kind of. Okay, so the idea is that, okay, I have these numbers, right? But I can, for the sake of training, reduce the efficiency a little bit, or the numbers a little bit, to make the processing faster, hence reducing my compute space. Okay, so it's almost one of the best analogies I read about this was converting a SVG image to a raster image, or converting a high resolution image to a slightly more pixelated image for fast processing, right? It's exactly that. The idea is to reduce it just a little bit, but because of this tiny reduction drops the weights incredibly. It makes the models extremely lightweight, right? That's very important, especially if you're using it to train on your laptop, right? You want to not be able to like completely jam your entire RAM or your entire compute space, right? So you want to be able to quantize it in a way that makes sense. So the reason I have these two images, if you see, these don't match up, right? Because this is a very tiny example of what we're trying to do. But so this is a floating point 32 being converted into an integer 8. And then depending on how you're converting it, the numbers and the weights will change. So here's a really good example of some calculation, right? So this floating point number is converted to integer, and this is a very fast GIF, but 32-bit converted to 8-bit, that is what we're trying to do. So depending on the type of conversion, your numbers will again vary, your weights will completely vary. Okay, so I'm going to leave this on for a second, and I'll share the PPT with you all. And there's a lot of images that I've taken from different blogs. Let me see if I can find the correct blog for this. But I did send you all already a bunch of really good articles on RAM calculation, right? So this is what we're essentially trying to do, right? Now, based on this, you then calculate the actual RAM needed, right? So RAM needed can be calculated either model parameters into quantization plus KV cache, or then there is this method to calculate, right? So if I'm calculating via this method and I'm taking a 7B model, it's going to take an FP16. So it's converting that into a quantized form, and based on how it's being quantized, so let's say you're quantizing it by 4-bit, this is going to be the total RAM that's required, right? That is how you decide, and that is how, when you go to different models, it's going to tell you the total RAM required, right? And then if you were to calculate it for an 8B parameter model using llama 3.1, which is 8B, and if you're using FP16 precision, right? So you all were talking about precision lowering. More than lowering, it's just about getting the precision. What does my precision have to be? How, depending, it's like if, let's say, you were doing computer vision, and I am trying to detect something very basic, right? Like, oh, the colors in the picture. I don't need it to be very high resolution, right? I can reduce the precision a lot and still get my answers. However, if I'm trying to detect a very specific expression or gesture, then I need to still optimize it by pixelating it, but I still need a slightly higher resolution, right? So, based on the application, based on how you're trying to use, your precision level can be adjusted, your quantization can be chosen accordingly. Does that make sense, everyone? Does anyone have any questions about quantization and RAM calculation? It's a very interesting topic. I would definitely want you all to spend some time with it. I am trying to find the uh, mm, blog for which I sent y'all the GIF. So this is the one. This is the one that I got the GIF from. Definitely a lovely read. Okay. So this is the article for understanding. So I've sent you two articles in RAM and I've sent you two calculators of RAM. So if you go to these pages, so if you go to this page, this is the Hugging Face model memory usage calculator. And then I sent you another one, didn't I? Yeah. Then this is another one. This is a random one that I found. And then I was like, oh, Hugging Face has one too. So then I used the Hugging Face one to experiment. So if you all have any questions, I'm going to give you all a minute to gather your thoughts around this. And this is another article that I forgot to send you all on the history of open source LLM models. So give yourself a minute. If you all want to have a minute to go through the articles, I'm happy to give you all that. But yeah, this is a very important part of using open source LLMs. Hey Avinash, welcome. We are talking about open source LLMs and how to use them. And it's a very, very shallow overview session about how you would go about using open source LLMs. So we spoke about why we would use an open source LLM. And now we're talking about, okay, how do you decide to use an LLM, right? So let me show you all, actually give me a second, I'll show it to you later. I'll show you all Olama and LM Studio and how you can go about using that, right? So any questions here, y'all? If not, let me know, or we can always come back to this, right? So let's talk about the tooling very quickly, right? Um, when you're using open source models locally, you need to assign a bunch of tooling, right? So it's not just the model, but how do you actually leverage the model, right? So if you were running this locally, you would want something that can run the model, wrap around it, and basically become an API for you in the local version, right? Yeah, basically. So if you quantize it more, it's going to be more smaller and hence you can run it faster, right? It entirely depends on how much you're quantizing your weights and your data. So tooling. So you need something that makes your LLM act like or gives it an API like feel when you're running it locally, right? So LM Studio, Olama are great examples of softwares that you can use to get the model in your laptop, in your local machine, or any of your environments, and be able to use them and run them like you do the models anywhere else. So it's almost like a Docker for LLM, right? Uh, then you want to have something to basically run it in production, right? So VLLM is a very nice way to be able to do that. So VLLM helps you uh, have it, run it like it's in production. And then there is the Llama CPP, which is a library that helps you harness the powers of it, right? So you have the engine under the hood. The C++ library runs on everything. It runs on literally everything from a Raspberry Pi to your laptop, right? So that is another cool tool. So these toolings are extremely important to get started. However, you could possibly also use a Jupyter notebook. So this is the example I was talking about. So I'm going to send you all the link and I'm going to show you all very quickly the the Jupyter notebook that I was talking about. So this is a very good example of this. Okay, I'm going to have to stop sharing for a second. Share screen. And let's share this for a second and show it to you. Okay, so this is the notebook that I just sent you all. This is from this person who runs this YouTube channel. They've done a great job putting together. So Quen 3 is one of the open source models. that is available, and they've shown how you would go around doing it, right? So they've spoken about the Quen specific architecture. Every LLM has a different architecture. There's also a really nice, let me find that. So we have someone who actually queried ChatGPT and Anthropic models. They actually queried it, like spoke to them and understood the memory structure that goes into it. So uh, let me find that for you. So they reverse engineered the memory system that OpenAI and Anthropic use. So this is a really another really good article. But yeah, so this person basically speaks first about the structure. They also have given us links to other videos that are incredible, by the way. They then talk about how you would go about first setting things up, how to make sure that everything that you're doing is reproducible and like saved so that you can just call different modules and run them again. Then you configure the model. Attention helper, this is again deep technical stuff about the model itself. And then finally, there's a point where you bring everything together. So after doing all the embeddings and all of the attention requirements of different modules for your model to work, you basically bring it together in the end. So training loop is where you get everything together, right? And then the code goes on to show the different ways to finally use it, right? So it's a very, very cool Jupyter notebook and a very cool tutorial that I would highly encourage you all to spend some time if you all definitely want to like do a deep dive. So this was my plan. I really wanted to run this with you all completely, but I realized that it's not possible to actually go through every concept in depth. So what we're going to do is we're going to just look at all of this in a slightly more overview kind of a thing, right? So definitely if you get a chance, go through this. If you all have any questions and you end up going through this, do get back to me. Okay, so let us go back to our PPT. So I'm going to bring this here. Let's see. Okay, there we go. So this is the tooling, right? So the tooling is extremely important in terms of how you're setting up your thing. We also have something called LM Studio. So this is what LM Studio looks like. Now that we have a minute and we've taken the minute, let me just quickly show it to you. So this is, why is it not coming? Oh, there we go. Let's do this. Yay. So LM Studio, this is LM Studio. So basically you can come here and download any model and you can possibly go here and start using it. So this is again similar to Olama. This is what Olama looks like. Let me also show that to you all. So this is what Olama looks like. Again, similar interfaces. The idea is you can have your entire project, you can have a local terminal, you can have all your different folders and embeddings and have like, so you see there's a folder for text embedding and everything. So you can come here, use it. So I was just trying to query it like, this is a model which has not been trained. I've just downloaded the model and started using it, right? So you can again come here and query it and talk to it about, oh, how do you work? Or oh, and just talk to it like any model. It's an untrained model. So after this is where you can start training it, so on and so forth. And it's also telling you why, how much it used, and why it stopped, so on and so forth. Right? So these are again two very good tools that help you make your model that you're downloading instantly accessible and usable. Okay, so I'm going to close this and close this, and let's go back to the PPT. Great. So let's continue. We already did this. Working locally. So let's talk about working locally, right? So I just showed you all the LM Studio and I showed you all Olama. What do you think is another thing that you want to be able to adjust when you are running a model? What is the one parameter that you want to be able to adjust when you are working with an LLM locally? The personality, maybe, right? When you're using an LLM model locally, you want to be able to control and know its tonality, right? Temperature, exactly, right? And with you using open source LLMs, you can always set the temperature according to the use case. For example, if I was getting the LLM to be an AI assistant, AI coding assistant, I want the temperature to be extremely low. I don't really need creativity, right? So like zero point 0.1 on the one scale. And if I am asking it to be a creative writer, I'd possibly set it at zero point 0.7. I want some imagination, right? However, if I was getting it to write, but write technical blogs, it would possibly be around zero point 0.3, where I wanted to get the technical concepts right, but at the same time, have some bandwidth to write well, right? So temperature, great job, y'all. Thank you for answering, right? So as when you're working locally with an LLM, you want to be able to control the output, the temperature, and one of the major things that you want to control when you're working is the structure, right? LLMs generally have extremely unstructured way of working. So one of the major things you have to do when you are working with an open source LLMs is to give them a very specific way to reply or answer. Okay, which means that you have to very specifically ask the LLM that, hey, parse this out correctly. What do you mean? If you all are looking up answers, that's perfectly fine. You all are welcome to look up answers whenever you're like. And I, at any given time when I'm talking about a topic, if it's even a little bit complex, I will be sending you all resources, right? Because this is a fairly intricate topic, right? Based on how much you know and what background you're coming from, it is going to vary a lot in what you understand. Okay, great. Let's continue. And yeah, feel free to look up answers whenever you feel like it, right? So output structuring is a big thing with LLMs. But the one thing with output structuring is when you're doing the whole JSON thing, uh, it is incredibly important to make sure you're passing it right. Otherwise, you can also lose context if it's not passed correctly, right? How LLMs handle data is one of the things that we spoke about in the MCP server stream, and it is always nice to know and understand how it works. RAG! Have y'all heard about RAG? What do you think RAG is, and why do you think it's important? So, if you didn't attend that session, to very shortly put it, MCP servers are one of the reasons. One of the reasons they exist is to standardize the input and output format of LLMs, so that when LLMs are ingesting the data and outputting the data, it's very simple, right? That is a very good way to put it. To ground the response, that is an incredible way to put it. Exactly, right? This is the best way to put it. Thank you so much for your answers. Exactly, right? But why do you think RAG is important? Why not just connect it to a database? So the idea is similar to quantization, but in a different way, where you want to optimize all the text, all the things that are words or non-digital, not digital, non mathematical terms into mathematical terms. So the idea is you take the structured and unstructured data, you make them into chunks, you convert them into embeddings. Embeddings is literally transmit like changing the data into numbers, searchable numbers, and then you retrieve the chunks to generate the response. The idea is to convert it first into numbers that the uh, LLM can ingest and process. That is another very good way to put it, right? So that is why RAG is extremely important. I had a really nice article for y'all on that as well. Let me quickly look that up. Mm-mm. Nope, nope, not this, not this. Okay, I think I accidentally closed that article, but too much articles. I agree, but the idea behind sending you all so many articles is to make the learning unbound. Like, instead of me just giving you interpretations of knowledge, I am giving you access to the actual article. That way, if you ever try to follow the notebook or try to follow any other video, you have a lot more resources to combine knowledge from than just rely on my interpretation, right? But yeah, I have actually a lot more articles lined up for y'all to do the exact same thing. Okay. But yeah, so RAG's extremely important, right? So here is an example of how you would use a RAG, right? I'm going to give you all a minute on the slide to go through it. This is Olama code. Okay. Olama is, again, just to go over it. No, we don't need to. We also need to prompt it, but we also have to make it the part of the agent itself or the model itself, where we're telling it, hey, when you are giving the structure, like when you're giving the output, make sure you give it in this structure. I can send y'all the code for that. Let me open my Olama and send you the structure for that. Mm-mm. Okay, while we're doing that, you can just look at the code that you're looking at right now, and I will try to find the correct code snippet for y'all. Uh, okay, it's taking a little while to load. Let's give it a minute. So this is the code sample. I'm just putting it in the chat. You can go over it. So sorry, this isn't very thing, but this the magic line, the comment that says magic line response format is what's very important to be able to make sure that you are enforcing the correct output, especially when you're working with it locally. You have to enforce this as a specific step when you're working with it. And if y'all have any questions about this, let me know. This is how you would set it up. You have the setup, then you're using the vector db. We are assuming that you already loaded the data, and then you are retrieving it using the db search, and then you're generating it. Okay, let's move on. Exactly, and that is where okay, so this is fun because you asked this question, right? Is a beautiful segue into this chapter where we're talking about RAG versus fine tuning. So let's talk a little bit about fine tuning. What is the difference, you think, between RAG and fine tuning? So, Satyasai, as you said, fine tuning is actually what is used to control the behavior of the LLM. RAG is used to give it information, right? So, RAG is what empowers your LLM with, oh, am I a doc a specialist? Am I uh interesting way to put it. But RAG is basically, oh, is what is the LLM an expert in? Is the LLM a mathematician? Is the LLM a doc specialist? What kind of doc specialist is it? So most companies with their AI based docs, they basically have used RAG to make sure that their entire information is fed to the LLM. But how the LLM talks to you? Does it talk to you like someone who is a technical professor versus assistant, whether it talks to you like a student? These are the things that you can control via fine tuning. Kind of a good, that is a pretty interesting way to put it, right? So I think I have a table here somewhere. Okay, so let's talk about first fine tuning itself, right? So we spoke about RAG. So the fine tuning makes the LLM more specific to the domain, and it reduces hallucinations. So it's actually what is the grounding effect, right? So someone earlier said that RAG is grounding, which is not untrue. It's grounding it in terms of the knowledge it actually is supposed to have. LLM, remember, is only a language predictor, right? We spoke about this again in the MCP session where we spoke about large language models are just text generators, but they need an information source and they also need a personality source, right? So fine tuning helps them become that personality. Am I a librarian? Am I a student? Am I a professor? What is the LLM, right? It Once it's trained, it has lesser retrieval delays, right? It's very quick once you also ground it after that. And once you have fine tuned it, it can work without that external source, right? Um, that is also a great way to put it, right? Limitations, it's obviously very GPU heavy, which is why a lot of companies that get fine tuning right do really well. Uh, Once trained, you also have to keep retraining it for different specific tasks. And then, yeah, you need to make sure that the context is always present, because this is a little opposite to hallucinations. But then, yeah, you need to make sure that all the data is balanced, otherwise it can overdo the task, right? And then we have a really nice table between fine tuning and RAG, right? um, from a cost point of view, again, remember we're talking about open source LLMs, right? So when we're talking about open source LLMs, we have to decide the cost between, okay, if I want to run it locally, maybe fine tuning it once is better than keeping the RAG going for longer, right? So yeah. And then, so for latency and computational cost, fine tuning is very high initial training costs, but very fast inference, right? RAG is cheaper to train, but there are retrieval delays, right? So remember, when I am doing a local model, I have to look at the trade offs and I have to decide based on the trade offs accordingly, right? Scalability, I think, again, trade off, right? Depending on the industry, depending on the company. If I'm a tech tool, I'm possibly updating myself very quickly, right? So RAG is probably better. However, if I am a medical tool or a medical assistant, fine tuning is better because I want lesser hallucination, I want more grounding, and the knowledge, basic knowledge, won't change a lot, right? Does that make sense, everyone? Then there's knowledge retention and hallucination risk. Obviously, fine tuning has lesser hallucination because we're grounding it and we're making it very specific to the knowledge that we're encoding in it. So with RAG, because we're relying on external sources technically continuously, there is higher hallucination risks. But again, remember, there's always going to be a trade off. So you're going to have to decide based on how you're trying to use it, what you're eventually implementing it on. I also have a really nice article that I've picked up the table from. So I'm going to send that to y'all. I have a really nice article on RAGs first. So let me send that to y'all. And all of this, by the way, is not just the article itself on RAG, but specifically in context with open source models, right? Which is why I gathered the material up in terms of just, okay, I'm sure you all understand what's a RAG or benchmarking, but what about when you're using open source models? The biggest factor is limiting factor is you wanting to use it on a local machine. So you want to make sure that it is well grounded, optimized for not overdoing on the resources, so on and so forth, right? And then I have a really nice article on RAG versus fine tuning. So let me send you all that as well. And then, of course, when you go through the article, if you all have more questions, feel free to come back to me. Oh, did I send you all the article on basics of quantizations? I don't know if I did. Let me send you all that as well. I have so many articles open for you all here, and like, I want to make sure you all don't have any questions once I finish the topic. So this is the one, really nice one. So it's like basic concepts of quantization, and they've done a really good job explaining the basics, including like very basic calculations and everything. So I'm gonna give you all a minute to catch up with that. And then we're gonna talk about something very cool. Have y'all heard of LoRa? Have y'all heard of LoRa? I think I have one image for this, but I have an article for y'all for this as well. So have y'all heard of LoRa at all? Maybe a game character. So LoRa stands for lower rank adaptation. The idea behind low rank adaptation is, okay, remember I have been constantly talking about, I know I sound like a broken record, but I've been constantly talking about local optimizations and optimizing for lower resources. Low rank adaptation is takes it a step further, right? So what was one of the biggest problems when you are trying to optimize an open source model locally, especially if you're using a RAG or you're trying to fine tune it, right? Tiny constraints. You have very little resource that you can play around with, right? So low rank adaptation basically is an idea that you freeze the main model and then you adapt tiny layers on top of it, and you can basically fine tune an entire model in lesser resources over a longer time. So you're basically trading off the time for the entire model to be optimized on lower resources. So let's say my model could have been trained in 20 minutes if I had so and so GPUs. If I reduce the number of GPUs, and I still want to train the model, I do low rank adaptation where I do the adaptation in layers by freezing tiny parts of it. So it takes a longer time, but it still does a good job. Does that make sense, everyone? So you basically keep training the adapter layer and keep changing the weights accordingly, right? So I have a really nice picture and an article for you all. So let me find that article. I know you're tired of so many articles, but I really want to make sure that y'all go back with no questions. So this is a beautiful article on fine-tuning LLMs with LoRa. And if you go to the article that I've sent, it's talking about how you can, it's talking, and again, the precision will matter, right? So let's say I want a local model to have a higher precision, but I don't have the compute power. So I go for LoRa where I know it's going to take longer, but I can have a higher precision, but a better model. Right? So if you all are going through the article quickly, I'm going to give you all a minute to do that because I know I told you all and I promised that it's going to be a short stream. So I'm going to stick to that promise. But yeah, so the idea again of the stream is to make sure you all get a very good idea from a surface level on the whole process of, let's say, one of you has to open a company using an LLM from scratch, these are the basic steps you would go through, right? One is choosing the model. Then the choice of the model will also depend on the RAM that you have, the VRAM that you have, the compute time that you have. Then, based on fine tuning and RAG, you'll decide based on your application what kind of personality, how fast and how precise you need it to be. Based on, again, your compute resources, you choose LoRa or not, on how fast you want to tread over it. And then finally, is that it? Is that it? Do I just deploy it now? Not really. You have to still judge it. Remember, an LLM, even after so many precautions, after so much, can still mess up, right? So you need to make sure you have an pipeline. Have you all heard of LLM evals? Have you all heard of eval pipelines, LLM evals? Do you know any company that does LLM evals? So one of the companies I know that does LLM evals is Maxim Evals. Let me see if I can find the link to them. Maxim AI. So I'm going to send you all the link to it. These are one of the folks that do evals, but there are a bunch of companies out there. The idea of evals is, okay, I did all the hard work, right? I went through all these processes, I've done all the steps, I've connected my data, I've created the loop. How do I know it's still working correctly? Should I sit down and test it myself? Should I get a testing team set up? How do I test it? So you put an LLM as a judge. Does that make sense? The idea is, oh, okay, LLM is now working, but now I use another LLM to judge the input and the output, right? So the idea, I think I have a really good image for this as well, right? So LLM as a judge is this, right? You have a prompt, right? You have the app in production and you have the response. So this is happening, your LLM is working here. However, the evaluator has to be another LLM. You put the prompt template, you put it through the evaluated LLM, LLM generated eval, right? So the eval is doing this. Your application is still in the mix where it's actually giving the answer. But these LLMs are actually evaluating whether or not the LLM did well, which is kind of funny, right? Like you're basically getting an LLM, a robot, to judge another robot. Not like Docker. How do you mean like Docker? Not like Docker at all. Did it make sense though? LLM as a judge. So LLM evaluations are extremely important. Any good not no. So okay. Exactly. It's like a okay, so it's like, okay, I make an application, right? And I'm very happy with it. And my company is very happy with it. But how do we know that it's actually a good application until a user tests it out, right? Now imagine you put the LLM out there and the LLM is continuously giving wrong answers or hallucinating. You can't test that out, right? So what you do is, before you put the LLM out, you actually make another LLM use it. So the LLM itself can give it, again, a lot of prompts, see the answers, evaluate the answers, and decide whether or not it's hallucinating, whether it's giving the wrong answer, correct answer, so on and so forth. That's a great question. So you do that by giving it test cases. So if you look at Maxim AI, the link that I sent you, they basically have created a UI. Their entire dev tool is basically creating a UI where you can see how the evaluation is happening. So you see the prompt that the LLM gave to the LLM in production, the answer it got, and how it evaluated it. So you can first figure out the test cases, make sure that that's correct, and you can always iterate through all these different LLMs based on the tool that you're using. Does that answer your question, Satisai? But that's a great question. So the whole idea of evaluation tools is that, by the way, all the steps that we spoke about, there are dev tooling companies trying to do that, right? So we have entire companies doing inferencing, right? Inferencing is basically the part where we spoke about the ingestion of the whole data, right? Let me send you a good inferencing company. So base 10 is a great inferencing tool, right? This is base 10, right? And every part of the step that we spoke about, uh, there is some company trying to make that step more efficient, right? There's another tool that is only doing LoRa. So it's just helping you do the maximizing the low rank adaptation, right? So every tool that you there's every step has a tool that is trying to do that with AI, right? Because that itself is such an important job, especially if you're deploying AI as one of your main stack tools. Make sense, y'all? Okay, I'm just going to quickly go through and make sure that I did not miss any articles. This is a really nice article on LLM as a judge. So it's going to answer a lot of your questions. And if you all look at the articles, they're all extremely lengthy. Okay. And if I were to do, we could basically do an entire article in an entire 2 hour session. But because we're covering everything on a lower level, I have made sure that you all have resources to go back to, right? Do you all have any questions about any of the steps that we went through? Does it make sense? So, as a homework or for y'all to go back and get started with this, download LM Studio or Olama, whichever y'all like better. Y'all can go through the docs. I've been trying to experiment with both. It's a very good place to start. I think one of the things I forgot to talk to y'all about was LangChain and LangGraph. So the local RAG stack. So we spoke about RAG, but there's the local RAG stack, and then there's the cloud one. So uh, so distracted. But the local RAG stack includes LangChain and LangGraph that help you basically do the RAG locally. I don't know if you all know, but Sid used to be another coach. He hasn't been for a while, but yeah, welcome, Sid. Folks, we're almost done. And I know I have put you all through a lot of articles. Take your time to go through with it, right? So, beyond chat, you can. This is again at this point, by the way, we've only set up the chat LLM, right? After this is where your MCP servers, your tools come into the picture, and that's when you start using the agent itself, right? So this entire process that we spoke about was just setting up the open source LLM and getting it to be useful in one context, right? So after this is when you go beyond the chat, you actually attach tools to it. And again, we went over this in the MCP server workshop. Thank you, y'all, for joining in. If y'all have any questions, keep them coming. I am obviously there on Discord. Feel free to tag me when you're asking questions specifically about these topics that I have covered. And I hope the articles are useful. Someone asked for the slides, so let me send you all the slides link right now. Before I forget, so I'm going to quickly send you all the slides links, and then I haven't attached all the links that I've sent in the chat to the slideshow, but I'll try and do that by today evening so that y'all are all sorted when you get to trying these things hands on. All right, folks, thank you so much for joining. Thank you, Satyasai, for joining and all the amazing questions that you asked. Great questions. And I will see y'all next GHW. I know this is the last stream of the GHW this time. And yeah, I hope you all had fun, and I'll see you all sometime next year in one of the GHWs. Bye, y'all.